In this lecture, I will share some very important points about angular momentum. Angular momentum is the property of a rotating body. Suppose a body is rotating in a plane about an axis. Suppose this is axis of rotation of the body. When the body is moving, it has some linear velocity, means it has some linear momentum. The moment of this linear momentum about the axis of rotation is called angular momentum. So we can define angular momentum as moment of linear momentum about axis of rotation. This is the definition of angular momentum, and this angular momentum is denoted by capital letter L, and its magnitude can be calculated by using this definition of angular momentum. Now, how to find moment of linear momentum about this? Suppose this distance is r from the axis of rotation. If I produce this line further and this line of linear momentum backward, then I drop a perpendicular over here. This is foot of the perpendicular. Suppose this is point O, this is point A, this is point B. Let us suppose this is unit vector r in this direction. Angle between r cap and linear momentum is theta. Let us suppose. If this angle theta, this angle will also be equal to theta, vertically opposite angles. So what is the meaning of moment of linear momentum? Moment means you multiply magnitude of linear momentum with perpendicular distance of line of linear momentum from the axis of rotation. As is clear from this diagram, the perpendicular distance is distance OB. Means we have to find the value of OB. From this triangle OAB, from triangle OAB, sin theta can be written as equal to OB divided by hypotenuse OA. Cross multiplying, I can obtain OB is equal to OA sin theta, and OA is equal to R, that is radius of circular path, it is R sin theta. Now if I put this value of OB equal to R sin theta here, I can write L is equal to P multiplied with R sin theta. It is Rp sin theta. So this is the answer for magnitude of angular momentum. Now R is a vector quantity, P is also vector quantity. So this right hand side is nothing but magnitude of cross product of R vector and P vector. So in vector form, I can write L vector is equal to R vector cross P vector. Hence the required complete relation for angular momentum of a rotating body. So this gives us another definition of angular momentum. Angular momentum is nothing but the cross product of radius vector and linear momentum vector of the body moving in a circular path. Now the next point is, what is the direction of angular momentum? As I have proved earlier, angular momentum is cross product of radius vector and linear momentum vector. So by using right hand thumb rule for cross product of vectors, we can find direction of angular momentum. As I have shown in earlier diagram, if we have this direction of r vector and direction of p vector is this one, how to find vector direction of L vector? This is the axis of rotation. For that purpose, I will curl the fingers of my right hand from r vector towards p vector. Then thumb will give the direction of L vector. So this is the direction of L vector along axis of rotation.